All right, so hopefully everyone can see my slides in slideshow mode here.
Yep.
So as Patrick said, my name is Antonin, and I live and work here in the US. I'm a staff engineer for VMware. I actually joined VMware pretty recently. I was at a startup company before, so I've been at VMware for about a year, and all of that time has been spent working on a new project called Project Antrea, for which I'm one of the maintainers. And I spend most of my time on it, and I'm very happy to be here and grateful to Patrick to have this opportunity to talk to you about Project Antrea and what it is. I put the link to our website here, antrea.io, and also the link to our GitHub page. So Antrea is hosted on one of the VMware GitHub organizations. And if you have any questions after this presentation, feel free to reach out to me at this email address. So what is Project Antrea? Well, Project Antrea is an open source CNI network plugin providing pod connectivity and network policy enforcement using Open vSwitch for Kubernetes. And so, well, that's a lot of like keywords here. And so everyone should be familiar with Kubernetes. Some of you may have heard of a CNI, which stands for a Container Network Interface. It's a standard interface or API for configuring network interfaces in containers. Open vSwitch is also a popular project. It is a programmable software switch that implements the OpenFlow SDN protocol and has been around for about a decade, I think. And as part of this presentation, I'm going to get into more details about CNI and Open vSwitch, and then I'm going to do a demonstration of how we tie everything together in Antrea. So before we actually dive into the presentation, I'm also going to start the creation of the Kubernetes cluster I'm going to be using for the demo. So it's kind of like a bit of a YOLO demo here. I hope everything works out correctly and that my internet doesn't go down or the cluster creates correctly. So do a demonstration of how the cluster is going to take about like 5 minutes to create. And during that time, we're going to be talking and moving forwards in the presentation. Hope I can show everything I want to show you. Here are a few stats about Project Antrea. So it's a really new project. We started working on it in July last year, so when I joined VMware. And Project Antrea was open sourced by VMware at the end of last year during KubeCon US in San Diego. Basically, VMware has a lot of experience shipping end-to-end network solutions for virtual machines and containers, as illustrated by like a successful product like NSX. And Project Antrea is really about VMware wanting to use this knowledge and experience to contribute to the Kubernetes community. VMware is also very active in Kubernetes in general. And since launch, the project has picked up quite a bit of momentum. As shown by those stats here, we have about 600 GitHub stars, almost 100 forks now, about 25 contributors, and more than 50K download of our Docker image, which is the way Docker is how we deploy Antrea in clusters. And so we're really looking to increase external contributions at this stage because we want to, we'd like Antrea to become a CNCF sandbox project. And VMware would really like to donate this project to the CNCF. So you're probably all familiar with Kubernetes, but all of you may not know the specifics of the Kubernetes network model. So the basic execution unit in Kubernetes is a pod, which can include one or more containers. And the network plugin in Kubernetes is responsible for configuring networking for the pod. So each pod is going to receive its own IP address, which is going to be unique in the scope of the cluster. It can be an IPv4 address or an IPv6 address, or if you're using like the dual stack experimental feature in your cluster, then both an IPv4 and IPv6 address. And one basic premise is that by default, all pods can communicate with all other pods without NAT and without any IP rewrite. And so by default, Kubernetes comes with a very simple network plugin, which is called KubeNet. It's just going to create these interfaces for pods on Linux, connect them to a Linux network bridge. And however, it has several limitations. So it's only going to work on Linux. It does not implement Kubernetes network policies. And we're going to talk about network policies in the next slide. And it does not itself handle cross-node networking. So pods on one node cannot talk to pods on another node by default, unless you program some routes or unless KubeNet collaborates with underlying cloud provider infrastructure if you're running your cluster on the cloud to basically program the underlying fabric. Fortunately, there are a lot of third-party network plugins which implement the CNI interface and don't suffer from the same limitations as KubeNet. Maybe you heard of Calico, maybe you heard of Cilium, or Weave, or Flannel. Well, basically, Antrea is also one such third-party network plugin. So I talked about pods, but there are two other Kubernetes objects which are very important when it comes to Kubernetes networking. I'm assuming people already know what a service is. It's an abstract way to expose an application running on a set of pods. So the usual workflow, and it's kind of like the workflow we're going to do for the demo at some point, is that you create a deployment object for your application, which is going to create a set of identical pod replicas. And then you're going to create a service object, select all of the pods created as part of the deployment as endpoints for your service. What happens is that Kubernetes then allocates an IP address, which we call the cluster IP. So like a virtual IP, and it's not part of the same network as pods. And the traffic that you direct to this IP is going to be load balanced across all endpoints for the service. In most clusters, this is done by using kubeproxy, which you're probably familiar with. And on Linux, kubeproxy is going to be configuring the firewall, typically IP tables, to do the load balancing in a random fashion between the service endpoints. However, you have some third-party CNI plugins, and I mentioned like Cilium last slide, which can implement that service cluster IP functionality for you, and then you no longer need to deploy kubeproxy in your cluster. And that's also something we're working towards in Project Antrea. And finally, the last object I want to talk about is network policies. And so, as I said earlier, in order to use network policies, you're going to need a third-party CNI plugin. You cannot just use a KubeNet. And a network policy specifies how pods are allowed to communicate with each other, essentially. So when you first define a network policy, and I have an example here on the right-hand side of the slide, you first select pods, typically using labels, to which you want to apply this policy. You then define a set of ingress roles, basically who can talk to the pods you've selected, and a set of egress roles, who can the selected pods talk to. And for those roles, you can select pods, but you can also select namespaces. And it's important to understand that a network policy in Kubernetes is itself a namespace object. In the example here, you see that I'm using namespace default. So it will only apply to pods within that namespace. And that means you can use RBAC to control who can create network policies in each namespace. So that very simple example here is just creating a network policy in the default namespace. It's selecting all pods with the label application is equal to web server to apply this policy to. And it defines a very simple ingress role that says that the only pods allowed to talk to my web servers are pods with the label application is equal to web client. And that communication can only happen using the TCP protocol on basically the default HTTP port, so 80. So now that we have an idea of what Kubernetes networking looks like, we can take a look at Open vSwitch, which is also called OVS, and why with Antrea we chose to build a Kubernetes network plugin based on Open vSwitch. Why not something else? So Open vSwitch is a high-performance programmable virtual switch. And a virtual switch is used to connect virtual machines. Typically, that's done on Linux, at least using tap interfaces. And connect containers. And that's done typically using these interfaces on Linux. OVS has been a Linux Foundation, project, I believe, since 2016. It's widely used in production. I think it's a popular implementation for the OpenStack Neutron plugin. You have companies like DigitalOcean, I believe, which are using Open vSwitch in production in their data centers. And it has a very active development community with a lot of support for hardware vendors, because it's actually quite easy to offload the OVS data plane to physical network interface cards and achieve very high performance. OVS is really a part of the Linux ecosystem. It's well integrating with Linux, and the OVS kernel module, which provides high performance forwarding, is available in mainstream Linux and has been available in the Linux kernel since version 3.3, which means that basically OVS will work out of the box in practically all Linux distributions which are available, as long as they use a standard kernel. And even like so-called cloud provider container optimized distributions like Amazon Linux or the new Amazon Battle Rocket, which is available on AWS, they come with this kernel module, so they can support OVS. And so I mentioned here at the beginning that OVS was programmable. So what does it mean exactly? Well, can I use OVS as a drop-in replacement for a Linux bridge? Yes, I can. And it's just going to act as a regular L2 learning switch. And I can connect like containers or VMs in the same network namespace, but that's not very interesting. What OVS lets you do is it lets you define your own pipeline. So basically, you can choose which packet header fields you want to match on as part of packet processing, and which actions you want to perform on the packet based on the result of those matches. And OVS supports a lot of different actions you can use, and it also supports many protocols. And in particular, it supports a lot of tunneling protocols, which means it's very easy to build overlay networks with OVS. It supports GRE, GNI, VXLAN, STT, so very easy to build overlays. So how do you program an OVS bridge? Well, this is done through the OpenFlow SDN API. I'm not going to get into too many details here, but that's a feature-rich, stable, well-documented API that basically is like directly connected with the whole SDN paradigm. And so finally, unlike the Linux bridge, OVS supports high-performance packet I/O when it's needed. And even though the kernel data path, which I talked about a minute ago, is the most commonly used data path in OVS, there is also a data path that runs in user space and which supports DPDK and AFXDP, which is a recent kernel bypass mechanism to achieve high performance. So basically, to get the most performance, you need to run DPDK inside the containers and use DPDK with OVS. Which means that it's only applicable to very specialized applications, not just your top-of-the-mill web server, but it's very useful for throughput-heavy applications, for example, when doing service function chaining at the edge if you're a telecom operator. And to make things a bit concrete, I'm like included that slide that shows how you can basically like play around with OVS a bit and discover all the possibilities. And this example here I'm showing is basically like the most simple example I can come up with, which shows like OVS functionality, which is why I called it the Hello World OVS program. And that kind of stuff is I often do myself when I experiment with OVS. What I like to do is on Linux, I like to create two different network namespaces to basically kind of like simulate containers. And I like to connect them to an OVS bridge using VE pairs. And here, that's exactly what I did. If you look at the diagram, and I assigned IP addresses to interfaces in those two network namespaces so that they're basically on the same subnet. And once I create my OVS bridge and attach those VEs, so those containers to this bridge as ports, I can basically ping a network namespace B from network namespace A by execing into that network namespace. And everything is working. Why is it working? Because by default, if you don't do any programming with your OVS bridge, it's going to behave like a Linux bridge. So it's going to take care of doing the L2 forwarding, which means those two network namespaces can communicate over IP. However, and this is this line here, I can use one of the OVS command line utility to add a flow to program my OVS. And this flow is going to say that all ICMP packets are going to be dropped. And I give a priority of 100 to that flow so that it has a higher priority than the default behavior, which is Linux bridge-like behavior. Now, after I install that flow, if I try to run the same ping command between network namespace A and B, now it's going to fail because all those ICMP packets are going to be dropped right away. And if I use OVSOFCTL, one of the command line utilities, to dump all the flows program into my bridge, I see that I have two flows. I have this flow with priority 0, which is the default L2 learning switch behavior. And the normal action here is kind of like a keyword that says you need to behave like the Linux bridge. And then I have my flow, which I added with priority 100, which is going to take care of dropping all the ICMP packets. So before I dive into Project Antrea, let me quickly check on the status of my cluster creation here. All right, completed in 11 minutes, so we'll be good for the demo in a couple minutes. So hopefully I gave you a better idea of what OVS is. But why did we decide to use OVS to build the Kubernetes Network Plugin? And another legitimate question is, why did VMware even decide to build an open source another plugin when it seems that we already have a somewhat rich and diverse ecosystem, right? What about Calico, OVN, Weave, Flannel, Cilium? Those are all like CNI plugins, Kubernetes Network plugins with some degree of popularity. Well, the ecosystem is actually not as diverse as one may think. A lot of these CNI plugins basically rely on Linux networking primitives, right? So Calico and others rely on IP tables to implement network policies. Cilium uses eBPF, extended Berkeley packet filters, for its data path, which is kind of like a recent take on an old technology in the Linux kernel that lets you execute bytecode in the kernel. And eBPF lets you do some pretty advanced stuff, some pretty cool stuff. But once again, my point here is that this data path technology, kind of like IP tables, is specific to Linux. What we think that OVS brings to the table is some interesting perspective. It brings some interesting perspective to Kubernetes networking. OVS is portable, and that's not something I've mentioned before. So we can have both Linux and Windows support using pretty much the same data path. So by Windows support, we don't mean some hacky support put together at the last minute, right? Because we can run OVS on Windows and have the same data path with the same match action pipeline, Windows support becomes a first-class citizen. And that's a bit unusual in the world of Kubernetes networking and even in the world of Kubernetes in general, because Windows support is kind of like still a recent thing, and it's not like very well supported at the moment in terms of the ecosystem. Of course, you still have some configuration, some plumbing work, which is different between Linux and Windows. But overall, the data path is the same, which means that whenever in Project Antrea we add support for a new feature, it should be automatically available for both operating systems. OVS is also programmable, as I mentioned before, and extensible, so we are not limited to vanilla pod networking, Kubernetes networking. We can build some pretty interesting features, for example, to provide visibility into your network. And also, we can implement the entire Kubernetes network model into OVS as one pipeline. That means that OVS can also implement cluster IP, and we can remove the need for kubeproxy, which is something we're actively working on and something that can lead to better performance. So you have that unified data path with very advanced visibility tools and something that's easy to debug because all the network functionality are concentrated into one place. In addition to supporting both Linux and Windows as operating systems, we want to be able to run Antrea pretty much in every Kubernetes cluster. And we have put a lot of work to make it happen. This includes things like cloud managed services, EKS, on AWS, GKE for Google Cloud, but also bare metal clusters, clusters built with VMware vSphere, do-it-yourself clusters that you may want to build directly in the cloud using like EC2 virtual machines, for example. And finally, one notable point is that Antrea was built specifically to implement Kubernetes networking, and it's specific to Kubernetes, and we try to use Kubernetes design principles and Kubernetes libraries as much as possible in the design of Antrea. So I don't want to get into too many details about this, but I talked a bit more about a bit earlier about the CNI interface, container network interface, which needs to be implemented by Kubernetes network plugins. So what happens is when a pod needs to be created locally on a node, a first kubelet, which is the Kubernetes daemon, is going to invoke the container runtime, for example, Docker. And this container runtime is going to be in charge of creating the pod and its containers. And as part of this process, the container runtime is going to invoke the CNI plugin through the CNI interface, the CNI plugin that you've chosen for your cluster. The CNI plugin is going to receive the request, the CNI add request. It's a very simple interface. And that request is going to include the network namespace for the pod. And all the containers in the pod share the same network namespace. It's then going to allocate an IP address from the pod network, create an E0 interface in that network namespace so that pod has a network interface. It's going to assign the IP address to it. And as a last step, it's going to connect everything together and connect that pod to the pod network through the E0 network interface. There is quite a lot of plumbing and routing to do to enforce the full Kubernetes network model. So you may have to like configure a default route in each pod, configure routes on the nodes based on the specifics of your Kubernetes network plugin. In some cases, you may have to even talk to the underlying fabric by using the cloud provider's APIs if you're running your cluster in the cloud. So it's more work than just creating a network interface. There is a lot of plumbing involved. Talking a bit more about CNI, it's also a CNCF project, and it's actually pretty independent from Kubernetes itself. It's a generic way to create networks for containers. And it comes with a set of reference plugin implementations, for example, the bridge plugin, which can connect all the pods on one node to a Linux bridge. And this is the plugin which is used as a building block for KubeNet, the default networking implementation in Kubernetes that I mentioned earlier. But you have other well-known plugins such as Mag VLANs to basically enslave the host interface and attach the pod directly to the host network physical network. However, all of those reference CNI plugins are not sufficient by themselves to implement Kubernetes networking. And this is why we have like third-party plugins which implement the CNI interface, like Project Antrea. And an important thing to remember is that CNI does not include network policies. Those are like specific to Kubernetes. So when you define a network policy, the CNI interface is not involved at all. It's up to the third-party plugin like Antrea to figure out what to do and program the data paths. So if we want things to get a bit more concrete, this is a diagram that shows some of the packet paths for Antrea. And in green, you have like the simplest packet paths, the intranode packet paths, where one pod on one node needs to talk to another pod on the same node. Well, in this case, really our data path behaves like the Linux bridge, as pods are in the same subnet. So the only difference really is that we're going to enforce network policies between those two pods because you can define a network policy that says that those two pods on the same node are not going to be able to talk to each other. In blue, you have the internode traffic. And Antrea by default uses an overlay network. By default, it's VXLAN to connect pods across that multiple nodes. And using an overlay network has like various advantages, right? Using that encapsulation can be advantageous. In my opinion, it's a simpler network model. It's easier to understand. It also works pretty much everywhere because it doesn't need to make any assumption with regards to the underlying network. It doesn't matter what that network is as long as your nodes can talk to each other. There are some cases in which you cannot use an overlay network. I mean, there is some encapsulation overhead, but in this case, Antrea can work in no encapsulation mode, assuming that all your nodes are on the same subnet. So in that case, you can avoid the overhead linked to encapsulation in terms of packet size and CPU usage. And in the future, we also plan to support BGP peering in Antrea, so that Antrea can exchange routing information with the underlying fabric and let that underlying fabric know where each pod is running. And this will enable us to support no encapsulation mode without making assumptions as to the underlying fabric and its topology. And if we dive a bit deeper into the Antrea architecture, this is what like a cluster looks like when you deploy Antrea. So really our data path, our data plane is a combination of like OVS and IP tables, but we're actively working on supporting service cluster IP in OVS and remove the need to deploy kubeproxy in the cluster. And I think the point I want to make here is that Antrea is really embracing the Kubernetes design principles and libraries. So it's very easy to deploy Antrea, as we're going to see in a minute. You can just deploy it with kubectl using a single apply command because everything fits into one YAML manifest. We have implemented a Kubernetes controller to watch the changes in network policy definitions and react accordingly. Ultimately, this means programming the OVS switches in the cluster using OpenFlow so that the policies are enforced correctly. At its core, Antrea has a distributed architecture, but policies are first processed by a central controller entity that you can see here. And communication between that central controller and the distributed agents, which run on each node, is implementing using the Kubernetes API server library, which is the same code used by Kubernetes to implement its APIs and to implement communication between kubelet and the Kubernetes control plane. And finally, we use Kubernetes custom resource definitions, CRDs. For those unfamiliar with them, it's a standard way to write extensions for the Kubernetes API. And we use those CRDs to report monitoring information, which can easily be accessed by the user, by the cluster operator. I'm going to cover this slide like very quickly because I want to move on to the demo, but this slide, and I hope the slides are going to be available online after this, basically shows the different pieces that constitute Antrea. And so the two major components are the agent, which runs on every node using a high priority Kubernetes daemon set, and is going to take care of configuring each pod's default network interface and take care of creating tunnels between nodes if you're using the overlay mode. Then the other major component is a controller, which is going to compute information about network policies and disseminate that information to all the agents. And other important components are the Antrea CLI, which I'm going to include as part of the demonstration, which can be used for debugging. And we also include an Octant plugin, so you can visualize information about the Antrea resources in the Octant dashboard, which is another open source project. Okay, let's skip over these slides because it just shows like network policy computation. We ran some scale experiments. And I mean, the idea of this slide is that Antrea performs very well at scale. It performs very well as you scale up the number of nodes and the number of pods in your cluster. And in terms of network policy implementation, Antrea really shines compared to a CNI plugin that uses IP tables, especially when you have a large number of short HTTP connections, because in terms of network policies, for whether you have IP tables and OVS or OVS implementation, because both of those tend to use contract for the implementation, it's really the first packet performance that's important. Because for subsequent packets, once you have an established connection in contract, performance is pretty much going to be the same because both are using contract to look up connections and take the necessary actions. All right, so now let's move on to the demo. So my Kubernetes cluster creation went well, hopefully. And what I'm going to be showing you is how to apply network policies in a cluster. I'm going to show the Octant dashboard integration. I'm going to show the Antrea CLI that can be used for debugging, and I'm going to show a bit of the Prometheus integrations that we have. And really, Prometheus is something we only started using in the last release, so right now we're not doing too much with it, but I just wanted to show what we have so far. So let me move to my terminal here. I have creating my cluster using some Ansible playbooks here. And so the different nodes, I have 2 nodes in my cluster I'm going to show you. I have 2 nodes in my cluster, which are actually Vagrant VMs. And right now they're in the not ready status. And they're in the not ready status because I've not deployed the CLI plugin yet in my Kubernetes cluster, which means that, for example, core DNS pods are basically broken right now. So in order to fix that, I'm going to deploy Antrea in my cluster. And I wanted to actually, I had killed Chrome before. I wanted to share my screen here. How do I do that? Sorry, I'm trying to move the browser to this window so I can show you. Do I have the... Oof. All right. So hopefully you can all see my browser. Please let me know if it's not the case. And I'm going to go to the Antrea GitHub here. I'm going to look at docs, getting started, and I'm going to... So this is a quick animation that shows how you can deploy Antrea. And basically, I'm going to follow those instructions, and I'm going to apply the latest version of Antrea as it is. So I'm going to download the... Actually, I'm going to download the manifest, so in case we need to look at it. And I'm going to deploy the latest version of Antrea, which we did about like a couple weeks ago. Let me retrieve that file. And now I'm going to apply it to my cluster. Here we go. We can take a look at the pods that are running in my cluster now. We can see that, well, the core DNS pods are pending, which is why my cluster is not in a ready state right now. My nodes are not in a ready state. But we see the pods creating for Antrea. We have 2 agents, one for each node, because the agent is deployed as a daemon set, and then we have our controller instance here. So it's going to take probably less than a minute to download those images. Are pretty small. Okay, we can see that the agent are starting here. Okay, so the agents are running, controller are running, core DNS pod are still pending. Oh, okay, now they're in container creating. So basically, we should be good to go in a minute. Okay, let's look at the node again. Okay, they're both in the ready state. So we've deployed Antrea. Right now, we don't have any application pods running in the network, but I've prepared. Sorry, that's what I wanted to do. Yeah, what I've done is I've prepared like a YAML manifest, and I'm going to show it to you here, which is going to create like a couple deployments. So one of the deployments is going to be running a web server. I have another deployment running some BusyBox pods, which I'm going to use as web clients. And then I have a third deployment, which I'm going to use to demonstrate network policies. And finally, I have a service, which is going to expose my my web server pods. Let me apply that manifest here. Okay. Let's look at the pods in the default namespace. All of those are being deployed in the default namespace. Okay, so it's taking a bit of time to deploy the servers. I think the image is a bit larger, but basically we have all the pods for 3 deployments now. And what I can do is I can exec into one of the client pods. Let's take, actually, let's look at the pod again, but this time use output wide so we can see which node the pod are running on and the IP address that the plugin Antrea assigned to each pod. So all those pods are running on the same worker node here because well, this is the only worker node I have in my cluster, and by default they're not going to run on the master node. So let's exec into this client pod here. It's a busybox pod, so let's use that shell. Okay. And now that we're inside the client pod, let's verify that we can talk to the server pods. Let's use this IP address, for example. Okay, we can ping it. That's good. And we should be able, it's a web server, we should be able to retrieve the the web page in that server. Okay, so we're able to download index HTML. Let's take a look at it. Okay, that's like the standard page for a new Nginx web server. Okay, so what we just checked is that pods in the we just checked that pods in the web client deployment can talk to pods in the web server deployment. Now I'm going to check that. I'm going to check the same thing for pods in the other app deployment. Okay, I want to use the same IP address. I think it was this one. It doesn't really matter, but okay, we can ping it, and we should be able to, okay, do a wget as well here. Okay, so far so good. Pretty much everyone can talk to everyone else. Now to the more interesting part. I have prepared a network policy here, which I'm going to apply to the cluster. And this is, I think it's the exact network policy I showed in the slides before. So what it says is that the only pods that can communicate with the web server pods or web client pods, and they can only do so using TCP on port 80. So once I apply this policy, I should still be able to do a wget from the web client to the web server. I should not be able to ping anymore because that's not TCP traffic. And if I look at my other deployment, the other app deployment, I should not even be able to do a wget from those because that would be denied by this policy. So we're going to apply it. Okay, the policy has been created. And we're basically going to run the same exact command. So let's start with our web client here. I think I need to remove index HTML. So let's try the wget. Okay, wget is working. So this is still working as expected because it's allowed by the network policy. And let's try the ping again. Okay, now the ping is not working anymore because it's implicitly denied by that policy. And for good measure, let's log into exec into our other app pod here again. And now let's try. No, index. Okay. Let's try our wget command, and this time it shouldn't work. Okay, because that wget is denied by the policy as well. Okay, so now that I've showed the basics of network policy, I wanted to show like a few things you can do with the Antrea CLI. And I'm going to head back over to my web browser here. What I'm going to do actually is I'm going to go to the release page here, look at our latest release. And in the latest release, we include binaries for the CLI, and I need the one for macOS here. You copy the link address. I'm going to need to download it. Hopefully, it's pretty fast. Okay, we're in luck. Good day for my internet today. All right. I'm going to rename it to just NCTL, and I'm gonna make it executable. All right. Okay. So now we can execute those CLI commands. I need to provide the path to the kubeconfig file here. Unfortunately, that has been fixed in top of tree in master branch, but there isn't a released version yet with that feature. We kind of need to provide the path to the kubeconfig file. It cannot use the kubeconfig environment variable like kubectl can here. And what I can do is I can look at the get commands I can do. Let's see, I think controller information is a good one here. So controller information is going to print some information about the Antrea controller, some things like monitoring information, else information, and some basic stats. This is a table output, so there isn't too much information. Let me output it in JSON format. Okay, here is all the information we give about network, about the controller in Antrea. Using the CLI, I can also get information about the network policies implemented by Antrea. The information here is not, this object is not the same as a Kubernetes network policy. You can query that from the Kubernetes API. This is just about the internal representation used by Antrea to implement network policy. So it's more used to troubleshoot issues with network policy implementation. I don't want to take too much time, so I'm going to stop here with the CLI, but you can also run the CLI within one of the Antrea agent pod and then get some information which is going to be local to that agent. So I wanted to move to the UI now, and I wanted to show how we integrate with the Octant dashboard to provide some monitoring information about the cluster and about Antrea specifically. So if I go back to we have some documentation information here about how to deploy Octant. Those information. So those are basically the instructions I want to follow here. I'm going to do them really quick. Let me see. I remember the path to the Octant file is this one, Octant YAML. Okay. And it's telling me to create a secret with my kubeconfig file because the Octant pod needs to be able to access the Kubernetes API, so it needs to have access to that kubeconfig. And I think the last step is because my kubeconfig has kind of like an esoteric name, I need here to rename to the actual name. I think that's all. Okay, hopefully that works. I'm just going to apply it. It's going to deploy Octant in my cluster. No, it's not in the default namespace, so let me. I don't remember which namespace it is. Yeah, it is in the kubesystem namespace. Okay, so I have that Octant pod. And now, well, I'm not going to get into too many details, but it's creating a service for Octant, a node port service. So I'm going to be able to access the Octant dashboard using that port number by using any IP address from one of my nodes. That's here. Okay, so this is the Octant dashboard. So Octant is kind of like a generic dashboard for Kubernetes. So you're going to have information about your pods, your deployments, your daemon sets, and so on. We don't have much in our cluster right now, but I guess if we go to deployments, I'm going to see, yeah, information about my my controller deployment and my Antrea deployment. It seems to, oh, okay, we are in the kube namespace, the kube system namespace here, so we don't see my web server and web client deployments, but if I go to the default namespace, yeah, here they are. Let's go back to the kube system. Okay, and what's specific to Antrea here is, and that's part of the cluster we developed, we basically summarize some information about the different Antrea components that you can visualize as part of this dashboard. It tells you that on this node, This is the Antrea agent pod. This is how many pods we're responsible to connect to the OVS network here. And because we expose monitoring information as CRDs, as I mentioned before, I can also go here into the custom resource definitions for agents, for example, and kind of like visualize those CRDs in like YAML format, and those have like more detailed information about the else status of different connections. You have some information about your OVS pipeline, the OVS version number, and so on. So it's a pretty good Kubernetes dashboard, and we've been able to leverage this to expose information about Antrea components. So Patrick, do I have some more time to show the Prometheus integration, or do you think I should like wrap it up here? Okay, thanks. So let me see. Okay, this should be pretty quick. We provide a YAML manifest, Antrea Prometheus, on our website. It's not part of the release package, so that's why I downloaded it here earlier. If I remember correctly, there is one thing I need to do actually. I need to enable metrics. I thought I had downloaded it before. Right now, we do not enable metrics by Prometheus metrics by default in Antrea, because it's kind of a pretty new feature. So what I need to do is I need to modify the YAML file for Antrea to enable those metrics, and then I need to redeploy my agents. That's just going to take a second. So I'm enabling Prometheus metrics exposure here by modifying the YAML file. I can redeploy Antrea. There we go. Let's look at those pods. Okay, the restart is like pretty fast because we already have the image now. See that one agent is not fully ready yet, but let's go ahead and deploy Prometheus in the cluster. I've prepared that YAML file here. So what it's going to do is deploy the Prometheus server, basically, so that it can scrape metrics from, well, pretty much everything in the cluster, whether it's Kubernetes control plane elements or Antrea objects. Okay, now that we've deployed services, let's take a look at those pods to make sure that everything's working. So we deploy them. Deploy them in the monitoring namespace here. Okay, and let me take a look at the Prometheus service here. It's also a node port service. Okay, we use port 30,000 for the Prometheus server. So I'm just going to be able to access this port just like I was able to access the Octant UI. Okay. Okay, so this is our Prometheus server. It's not like a great UI, but people usually use something like Grafana. We see our metrics here. Let me just check one to make sure everything is working correctly. Those are the Antrea specific metrics. Okay, we're receiving metrics information from the Antrea agents. Okay, that was a bit new for me, but last night I actually prepared, like, I installed Grafana on my laptop. I didn't configure anything, so I'm going to go through it now, but I can add, and yeah, Grafana is very new to me, but basically I think I can add Prometheus as a data source here. Oh, save and test. Okay, it's working. And let's see if we can do one simple query just to visualize one of those metrics in a more concrete way. So the one I was checking was this one. I think I can, restrict it by agent. So what this metric does is it gives me the number of entries in each OVS table in my pipeline. So it's kind of like convenience to visualize which tables have like a large number of entries and how that number varies in my cluster as I deploy more pods and things like this. So I think that's all we need for this. Let's go back to the dashboard here. Okay, we have our, let's reduce the time scale. Okay, so we see that we see the occupancy of the different OVS tables here. We have about a dozen tables or so. It's showing like one table, it seems like table ID 10 has like the largest occupancy with 25 entries. So these numbers are going to depend on how many pods I have. Can I zoom in? Yeah, are going to depend on how many pods I have running in my cluster. So actually, if I go back, okay, I haven't tried this before, but if I go back to my cluster and I look at the deployments I have, and I pick like the client one, for example, and I delete it, hopefully the metrics are going to get updated. Maybe I need to refresh. All right, so it doesn't seems like it's updated. I don't know if it needs some time. Let me go back to the Prometheus server here. Let's execute the query again. I don't know how frequently the metrics are pulled. Yeah, those pods definitely went away, so we should see like a decrease in the number of. Oh, here we go. Perfect. Okay, so the number of entries in the tables is going down because we've removed pods, so we need less forwarding logic basically in our OVS data plane. We have like some. Oops. We have some other like metrics, for example, specific to the controller. I think I can. There is one that's very easy to show, which is the controller has a lot of metrics related to like network policy computation and implementation. If I add this one, it's just a number of network policy internal objects that our controller has processed. Right now it's at 2. Not super interesting here. I mean, we have a very small cluster, so all those it's all running locally on my laptop. So all those metrics are going to be like pretty small and pretty static. But I think if I delete the network policy I created previously, maybe it's going to take a bit of time like before, but it should go down eventually. So that's it for the demo. Yeah, I'm not going to get into too many details over those slides. I think they'll be available online, but we've been like working actively to add like features as fast as we can and quality features. So here is a list of what we have so far. We also have like a pretty ambitious roadmap for the months to come. And we should actually have Windows support complete by the end of this month. So that's pretty big for us. And hopefully the next release is going to include the OVS native kubeproxy support I mentioned before, so that you no longer need to run kubeproxy in your cluster to achieve service functionality. We're also working like on a lot of integrations. Yeah, as I said, we have a very ambitious roadmap here. And I'm not going to get into too many details. If you're interested in participating, we have a community meeting every other week. So it's we try to have like a Europe-friendly time. So I think it's 9 p.m. PST. So well, I guess it's kind of like early French time. It's at 6 a.m. So it's a bit early. But we do record those meetings, and all the meetings are available in our YouTube playlist. Yeah, so I'm going to end on this slide here. Don't hesitate to take a look at the project and email me if you have any questions, or please raise issues on GitHub if you run into any issues while deploying Antrea. I'm just going to check that. Oh, that metrics never go down. My bad. So it's supposed to stay stable like this. Yeah, it's monotonically increasing. Okay, so I'm gonna add on. I'm gonna end on this slide. Thanks again, Patrick, for letting me present on your channel here, and I hope everybody learned something. And I'm happy to answer questions now.
I think you've answered all our questions. Cause
yeah, sorry, I took a bit of time. Actually,
no,
almost
that's
an
great.
hour. Yeah.
How long have you been working on Project Antrea?
So that's been like my main job at VMware. So I started working as soon as I joined, which was in August last year, and that was like a month after the project was created. So yeah, the project has been around for about 10 months, and I've been working on the project for about 9 months.
Okay, and how has been the community engagement so far? Has it been received well, or?
I think it's been good. I think people are potentially excited to have like a CNI project like Antrea be contributed to CNCF, because there is no, I mean, networking is an important part of Kubernetes, and no CNCA, no CNI has been like a CNCF project so far, and so for a project like Kubernetes, which is so in the open um, and governed by CNCF, we think that it's very important to have like kind of like a CNI which can be used as like some reference implementation of Kubernetes networking and is governed by the same entity and the same principles as Kubernetes. And I think one thing I'll mention is right now, for example, there is no actual network policy testing in the Kubernetes CI, continuous integration pipelines. And that's because there is no reference CNI implementation that implement those network policies. So the Kubernetes has like some code around network policies. It has like actually a suite of tests for network policies, but those tests are not even run as part of Kubernetes CI because there is no reference implementation. So we hope that we'll be able to donate Antrea to the CNCF, that it can become some sort of reference implementation, and that we can improve network policy and Kubernetes networking in general by doing so. And actually, recently there has been like a notable increase in participation in our Antrea community meetings, and I take it as like a very good sign. And we're working with some people outside of VMware to add some features. For example, we're working on Mellanox right now, which is a hardware vendor, so that they can support offload of the Antrea data plane to their network interface card, so you can achieve very high performance when you need it.
Okay. And could you tell us a bit more about VMware Tanzu? It's a group of lots of projects. Could you tell us a bit about it?
Yeah, it's a we call it like a portfolio of projects on GitHub. So actually, yeah, Antrea is part of this. Octant is part of this. But Tanzu also like is also some projects internal to VMware that we're actually going to support with Antrea. So I don't know if you've heard about Tanzu Kubernetes Grid, but basically TKG, this is like the Kubernetes distribution, which is going to be like signed by VMware and for which VMware is going to be offering support. So we're planning on using Antrea as one of the networking solutions for TKG. So yeah, the whole ecosystem is like projects around like Kubernetes, and they're all like we all try to integrate with one another here to have like a very good ecosystem.
Okay, is TKG open source?
I actually don't know, so I don't want to say something incorrect. If it is open source, it will be on the VMware Tanzu GitHub webpage, but I don't think it is. It's using some open source projects, but it's like I believe it's a commercial distribution of Kubernetes.
Okay, nice. Okay, is there anything else you would like to add before we end the podcast.
No, thanks. Hopefully, I did justice to the project, and maybe I didn't emphasize. I mean, I guess I showed it in the demo, but it's really easy to deploy in your cluster. So a single apply command, and it should work out of the box. I mean, I basically created a cluster from scratch on my laptop at the beginning of the presentation, and I had Antrea running in it by the middle of the presentation. So very simple to deploy, and hopefully some people will want to experiment with it.
Okay, perfect. Well, thanks, Antonin, and see you in another episode, maybe.
Yeah, and thanks again, Patrick. Thanks for reaching out.
You're welcome. Cheers. Bye-bye.
Bye.